Okay, see my screen is visible.
Yes, sir.
Okay. So see, I have created a folder in the desktop with the name Data Science Python. This is the folder, and I will use VS Code for this Data Science Python thing. You guys can use Anaconda Navigator also, or Miniconda base, or Anaconda base. If you have system requirements satisfying this Anaconda and Miniconda base, then you guys can install those Anaconda and Miniconda environment. But currently, I am using the VS Code for this, and the libraries you guys will need for this data science Python things. Those are NumPy, Matplotlib, and Pandas, and a little bit of SciPy. Okay, that means scientific Python. So let me open this folder first, data science Python, and I am opening this folder with VS Code. Okay, now see this folder data science with Python. This folder is now opened in VS Code, right? And in this thing, I will create a Python file extension with the name of .ipynb. Do you guys have any idea what is ipynb or what are .py files? Means the Python
Yes, sir.
extension is,
Dot.
yes, the Python extension is by default is known as .py, right? And what is .ipynb? Okay, so see, basically .ipynb are the notebook files or the Jupyter notebook files. Okay, so I am creating a program .ipynb. Okay, just wait and let this program.ipynb file to be created in my VS Code, because the VS Code connects with the kernel of the system interpreter of the shell that I have currently installed in my system. So it is you guys can see that it is showing the detecting kernels. Okay, so detecting kernels means the system interpreter the system Python interpreter which I have currently installed in my system, apart from Anaconda, Navigator, or Miniconda. Okay, you guys know what are Anaconda, Navigators, and Miniconda?
Yes, sir.
Okay, so I am currently not using this Anaconda Navigator or Miniconda. I am just using my by default the system Python interpreter version. I think which is supposed to be. Let me check on my CMD. That means in command prompt. Okay, I am see. You guys can see I am hitting a command Python space double dash version, and see this is my system Python version Python 3.11.1. Now I am giving another command pip list. So what does this command does? This command basically lists all the libraries or the modules or the frameworks which I have installed in my system interpreter version of Python, that is 3.11.1. Okay. So I told you that for this data science thing we need NumPy, Matplotlib, Pandas, and a little bit of SciPy. Okay, that means scientific Python. So I am checking the comments with the comment. I am checking with the comment p please. I am checking which libraries are currently installed in my system interpreter version. This comment can take something. Yeah, see. These are my libraries which I have installed in the version 3.11.1. You can see there is a library called Django. Okay, so Django is a Python full stack development framework. So this library is also installed in my system interpreter version 3.11.1. See, there is a library Matplotlib. Matplotlib is the data plotting or data visualization library. This library is also currently installed in my version 3.11.1. Okay, so there is also MySQL client. There is NumPy installed. There is Pandas installed. There is Pillow installed. Peep installed. There are lots of libraries installed in this version interpreter 3.11.1. So I am closing this. So see, now I am on my keyboard. I am just pressing Control Shift P on VS Code. See, Python select interpreter. See, there are few interpreter options in my system. There is a version 3.11.1 which is the recommended version, which is also called the system default interpreter. There is another interpreter which is the 3.9.13 and 3.10.9. Now these are the Anaconda Miniconda based interpreters. We are not currently using these interpreters. We are just using the system based interpreter. Okay. Now see, there is an option called select kernel. I am just connecting the Jupyter kernel from here. Okay. So select kernel Python environments 3.11.1. Okay, I have just connected this shell to this kernel of version Python 3.11.1. Right? Up to this, is this concept clear of creating this IPYNB file? Hello?
Sir, can you repeat uh, can you repeat after that when you return back to this folder, program.ipynb?
Okay. See, I am okay. I am repeating. See, there are two type of Python file extension. Okay. So there is a file extension which is also called means the default extension in Python, that is program.py. Right. This is the default Python file
Mm-hmm.
extension where we can write some Python program, like suppose we are printing print hello world. If I run this code, we are pressing this run button and this code will get executed and compiled in the terminal, and it will show the output hello world, right? And there is another extension in Python which is the .ipynb. Now .ipynb extension is the notebook or the Jupyter notebook files. What happens here is that there are a lot of code segmentations. Okay, suppose say there is a huge code, means there is a operational code. Okay, in that operational code there are four segments. You can divide those four operational code segments into four different parts using this .ipynb. Okay, now this is not possible using the normal program.py file. Why? Because this normal program.py file creates a Python file script, means a scripting file. This is a Python shell script or a scripting file. This .py means the default Python extension. Now this .ipynb, we can divide the entire block of code into different segments. See, this is a normal output. It is showing hello world, right? Now if I comment this code, now this line will not work. Okay, it is quite natural. And if I give something over here like a equal to 10, b equal to 20, c equal to a plus b, and print c, so it will normally give 30 as output. 30. This is the working of a normal Python file, okay, or a normal Python script file. But in advanced .ipynb file, what happens here is that we don't need this external system based terminal. We can just execute the code over here only, on the shell only. Okay, now in that purpose it is called shell. Now in this purpose it is called cell. Okay, each and every code is executed in a cell. So see, I am defining a Python class over here with the name of class test. How we define a function in Python? Using def keyword. Define def main. Suppose say in this I am printing hello world. Okay, now this with the help of the class test and my function name as main, I can run this cell. Now see, when this cell is executed, no, this output is printed below this cell only. Now in the same file I can write another code over here. Suppose say class test2, and I am defining another function def main, and I am printing something else, print Google. So class test2 dot main. See, now this is a single program.ipynb file where we are writing or where we are defining two classes, two functions, and we are executing two cells in the same program file only. But in the program.py file, we are just executing a single variable, means a combination of multiple variable we are assigning to a single variable, and we are printing some results or something. Okay, so this is a normal working of a Python file, and this is an advanced working of a .ipynb file. Did you understand the difference?
Yes, sir.
Okay. Now see, in data plotting, now here we can, what is the difference in normal Python means .py file, we cannot visualize any data. We can't visualize any data. Okay, so I am just removing these code cells. See, I told you that we need NumPy. Now, what is NumPy library? NumPy library is basically used for creating dynamic or advanced arrays in Python. Suppose say we are importing NumPy. First of all, this is NumPy is a library. We need to import it. So import NumPy as np. Okay, I am defining a class over here. Suppose say class plot. I am creating a function over here. df main. Now, in this, I will define an array. Suppose say arr underscore 1 equal to np dot array within bracket. Okay. Now print arr underscore 1 print arr underscore 1 dot ending and print. Now if I run this cell, now see, this is my array, right? Just a minute. Now see, this is my array. Okay, now the dimension of this array is 1, so it is showing 1 over here, and the type of the array, it is showing numpy array, right? So if I want to plot this array, we can plot this array using numpy. Oh sorry, not numpy. We can define the array using numpy. We can plot this array using matplotlib. So let me create few arrays over here first. Suppose I want to create user input array. So import numpy as np class. Okay, I have defined few coordinates of this array 1, right? Let me rename this array 1 to x axis for a better understanding. Suppose say x underscore axis. Okay, and I will create another array over here with the name of y axis. So y axis equal to np dot array, and I will change the coordinates over here. Suppose say 18. Okay, I have defined few coordinates of x-axis and y-axis. Now see, I will import another library over here. I have just defined this arrays using this numpy library in Python. Okay, now for data plotting, we will use import matplotlib dot pyplot as plt. Okay, so we have used over here import matplotlib.pyplot as plt, and we have defined two coordinates over here, x coordinates and y coordinates, right? So both the coordinates of x-axis and y-axis should have the same values, means the same number of elements. See how many number of elements are there in this x-axis: 1 2 3 4 5 6 7. There are
Right.
7 elements in the x-axis. How many number of elements are there in the y-axis? 1 2 3 4 5 6
Seven.
7. Right? So this x-axis and y-axis should carry equal number of elements for data plotting. Okay, so next thing what I will do now, this entire matplotlib library and this matplotlib library module pyplot, we have used this as plt. So we will plot this module. So plt dot plot within bracket, I will give the name over here x axis comma and plt dot plot y axis, right? And at the end I need to give to render the graph, that is plt dot show method. And my this entire program is under this class array and inside the function main. So dot main. Now just me run this cell. Now see, this is the simple graph it is showing. Okay, for the x-axis and for the y-axis. Now which one is x-axis and which one is y-axis, we can identify that using the color. But if you want, you can give your customized color also. Like we can customize this graph further. How? So plt dot plot x-axis I can give over here comma color equal to red, and for y-axis we can give over here color equal to, suppose say blue. If I run this, so you can identify that this red line. So this red line consists of these x-axis values. That means these 7 elements, and these y-axis values are with this is identified with the help of this blue line. Now the points where the points where the x-axis and y-axis values are plotted, we can identify it using this marker interface. So marker equal to, there are a lot of type of marker. So normally the most commonly used marker is the O marker, and for the same I am giving it over here for the y-axis also. Marker equal to, see, the points where these graphs are plotted are represented by dots now. Okay. Now there are another type of marker which is called a star marker. That means these dots will be changed into star. Okay. Up to this, is this clear?
Yes, sir.
Okay.
Sir, hello, sir.
हाँ बोलो, सुनाई नहीं दे रहा, बोलो जल्दी.
Uh, uh, we can use anything we want as a marker, or there are some constants.
There are a few constants of marker, like there are star markers, there are round shape markers, there are H markers, there are different diamond shape marker, there are hexagonal markers. Means there are marker patterns. Now where you can get these marker patterns, you have heard about the website W3 schools, right?
Yes, sir.
In W3 school,
Yes,
just
sir.
search over their matplotlib markers, or search over their matplot markers. You can see there are tons of markers over there, there are tons of marker interfaces over there. Okay. Means this marker
Okay, sir.
equal to within double inverted comma O, this is the most commonly used marker. Okay. But
Mm-hmm.
side by side there are lots of tons of marker. Means there are even such type of markers which are not evenly used in program also.
Okay, sir.
Okay. Now see, we can further customize this graph using the grid functionality. Now in the graph background, there are no gridding. Okay. So I can include a grid over here. So PLT. Okay. Now you can see there are background grids showing over in the graph. Background grids. Right.
Yes, sir.
Okay. Now we can further customize this using the color scheme such as MFC. Now what is MFC? MFC is marker face color. Okay. So I am giving the marker face color of the x-axis as yellow. And what is MEC? MEC is marker edge color, and I am giving the marker edge color as red. Okay. Similarly, over here also I am giving MFC equal to yellow and MEC, that is marker edge color, as blue. And the background grid of this graph, I am customizing this color to green. So color equal to green. Means the background color of this grid will change. Let me run this. Okay, now there is another thing that is called MS. What is MS? MS means marker size. So I am defining this marker size as, suppose say 4. And similarly I am doing this for the y-axis also.
So MS is the marker size, no?
Yeah, MEC,
Okay, sir.
MEC or MS.
No, sir. I wanna ask MS.
MS is marker size.
Yeah, sir. Okay, sir.
Let me further increase the marker size. Yeah, now see. Now is this clear?
Yes, sir.
Okay. Now, if I want to give the label and this x-axis and y-axis title, we can also give it over here, or we can specify it over here by plt dot. Okay, now see this the label, the title label of this x-axis, y-axis, and this graph title are now representing in this graph, right?
Yes, sir.
So this is the very basic data plotting or a data visualization of a two single dimensional numpy array. I am repeating again. This is a very basic representation or a data representation of a very basic single dimensional numpy array. Okay, and where we have
Yes.
used this plotting library, this matplotlib library, to plot two arrays, that is the x-axis array and the y-axis array, and both are these both are 1D arrays, and we have both plotted this 1D array in a single graph, in a 2D graph.
Sir, I have a doubt.
Yeah, bolo.
Yes, sir. If you want to add some extra graph line or extra line,
हाँ
like here it's given X or Y,
हाँ
and if you want to add Z or something or
हाँ
more
बिल्कुल
two
ऐड
to
कर सकते हो.
three.
मतलब मेरा मान लो यहाँ पे एक्स एक्सिस है, वाई एक्सिस है, तुम बोल रहे हो कि अगर मैं चाहता हूँ कि जेड एक्सिस भी यहाँ पे ऐड करूँ तो वो पॉसिबल है कि नहीं,
Yes, sir.
राइट?
Hmm. Yes,
बिल्कुल
sir.
पॉसिबल है. तो तुम अगर चाहो तो यहाँ पे एक नहीं तीन चार और भी तुम मतलब एक्सिस ऐड कर सकते हो. ओके, बट रिमेंबर देयर आर डिफरेंट टाइप ऑफ graph categories. This graph is normally called the line graph. Okay, this type of
Okay,
graph is
sir.
called line graph. Okay, in matplotlib there are few type of graph categories, like there are line graph, there are scatter graph, there are bar graph, there are pie charts. So these are the very basic category. This is a line graph. Okay, in line graph you can plot each and every axis in a different line. Okay, but in scatter graph or in bar graph we need to define the x-axis and y-axis coordinates simultaneously. Okay, means see,
Mm-hmm.
the coordinates I have defined for x-axis 10 and the coordinates I have defined for y-axis 18, these are not means interlinked. Okay, these coordinates are not dependent on each other, they are independent values. This 10 is an
Yes,
independent
sir.
value, this 18 is an independent value. These two values are not dependent on each other. But for a, suppose say for a bar graph, Now bar graph can be of two types, a horizontal bar graph or a vertical bar graph, right? Now in horizontal bar graph, if we define the x-axis and y-axis values different, okay, so that graph will not render, because in a x-axis there will be bar and in y-axis there will be the value of those bars.
Mm-hmm.
So this is the difference when we define a bar graph or a scatter graph. Scatter graph, means the x-axis and y-axis values are dependent on each other. Now for line graph, they are independent values.
Okay, sir. It means only in bar graph x and y are dependent on each other.
Yeah, you have to define a means a pair of x and y axis. Now you can see, you can define in this is in line graph, I have defined x axis, I have defined y axis. Now you are telling that, sir, I
Yes,
want
sir.
to define z axis. Yes, it is possible, you can define
Mm-hmm.
z axis. Now someone else is telling that, sir, I want to define b axis, or someone else is telling that, sir, I want to define c axis. So it is, everything is possible in line graph. Okay, but when this concept comes to the bar graph or scatter graph, we need to pair this, means this x and y will be a single pair, this z and b will be a single pair, this c and d will be a single pair. Like this way we have to plot this bar graph.
So can you show an example?
Yeah.
Uh, for
Okay, before moving to bar graph plotting, just let me show you. Now these numpy values I have defined manually, means I have embedded these array values in my system code. Okay, or I have hard
yes, sir.
binded these values in my script file. Okay, now what if I want to
Mm-hmm.
generate these values by my own? Okay, so how we can generate these values by my own? Suppose say I am defining x-axis over here, x-axis. Now there are two procedure. One procedure is to take an user input value, and the second procedure is to create random values. Okay, so I am showing the first procedure, x-axis. Before this, I need to import numpy. Import numpy as input. Okay, and I need to import random also. Random is a Python module which will generate random integer or random values. Okay, so x-axis equal
Yes,
to
sir.
np dot random dot randint within bracket 10 comma 90 comma 12, print x underscore axis. Now similarly I will do this for the y axis also. Okay, so my class name was test graph. The name of my class is test graph, and the function name is main. So test graph dot main. Now see what is happening over here when I'm running this code. See, there are two arrays it is generating. You guys can see two arrays. Okay, this is the first array, this is the
Yes,
second
sir.
array, right? My screen is visible, right?
Yes, sir.
Okay, now when I'm running this code again, this, see, the array values are changing. The elements of this arrays are changing. Why this is changing?
Because it's taking the random value. I think.
Yeah, it is generating random integer values. Okay, starting from
Mm-hmm.
10 to 90, and it is generating 12 values. Now I'm reducing this to 5. Now see, it will generate only 5 values. There are 5 random values in the first x-axis, and in the second y-axis there are 5 random integer values, and it will generate the value starting from 10 up to 90.
Okay,
Clear?
so first is the initial state, second is the final state, and the last one is for the number of value we want.
Yeah, 10 means that is the starting value, 90 means that is the ending value. That means this is the range from where to where we will generate random values. Okay, that means my limit or boundary. Okay, 10 to 90 is my
Yes,
boundary.
sir.
Okay, and how many number of values we are generating? We are generating 5 values for the x axis also, for the y axis also. Let me make it more means simple to means you can visualize it more simple. X axis, and for this y for y axis.